Hello students, I hope that you are good, well and fine. Today what we will be seeing is the derivatives of implicit functions and of inverse trigonometric functions. Okay, you will know after this session what do we mean by implicit functions, and also you will know what do we mean by explicit functions. So how we are going to find the derivative of such functions, and also we are going to learn about how do we find derivatives of inverse trigonometric functions. Okay, so in today's session we mainly focus on these two subtopics of continuity and differentiability, mainly differentiability. Okay, so let us move derivative of implicit function. So far we have differentiating many functions. Okay, but we used this form, yes, where y is equals to some expression of x. Yes, this means what? Function in terms of x, or in other words it represent expression in terms of x. Okay, that expression follows certain condition, that's why we are calling it as a function. Okay, now but it is not necessary that a function are always expressed in this form. Okay, it is not necessary. For example, if you consider x minus y minus pi is equals to 0, this is also an example, but not in that standard form. This form is not in this form. Okay, but you can change it. Obviously y is equals to pi minus x, you can write it. But if you look into the second form, you cannot express it as y is equals to fx form. You cannot. How you are going to split the sine xy term into sine, some expression of sine in terms of x and some expression of sine in terms of y? You cannot. Okay, so the second form, we are saying that such type of forms which cannot which are in x and y are both together. Okay, those form we are calling it as implicit forms, implicit functions. Such type of forms we are calling them as explicit functions. If you can able to write it down y is equals to fx, then at this step you can say your function is explicit. Otherwise you will say that my function is implicit. Okay, simple, explicit and implicit. So here this expression is implicit for now, but if you try to write it down like y is equals to fx form, or y is equals to x minus pi form, yes, x minus pi, then you will say that my function is now explicit. Okay, but below this expression, this equation is my implicit function. You cannot separate it. Okay, clear? Okay, so in the first case we can solve for y and write y is equals to x minus pi. Okay, this is now of the form y is equals to fx. In the second case, it does not seem that there is an easy way to solve for y. There does not seem that there is an easy way. We don't know yet. We don't know for now that we can separate it or not. Okay, or easy way. Nevertheless, there is no doubt about the dependence of y on x in either of cases. Okay, when a relationship between x and y is expressed in a way that it is easy to solve for y, and write y is equals to fx, we say that y is given as an explicit function of x. If you are able to write your function in such form, then you can easily say that your y is given as an explicit function of x. Okay, simple. Okay, now in the second case, where we saw the implicit function. Okay, so it is an implicit function. The case we are talking about was sine case. Y is a function of x, and we say that the relationship of the second type above given information gives function implicitly. In this subsection, we will learn how to differentiate implicit functions. We know about how to differentiate explicit functions. Okay, so far we have done that explicit function derivations. Now here we have to find what the derivative of y with respect to x. Okay, so this is for now given as implicit. If you try to write it down like this, y is equals to x minus pi, now it is explicit form. This is my explicit, this is my implicit form. Okay, now what can you say? So you want to find this thing. So in explicit form, how you find it? Very easy. You write what you write. dy by dx, you know that x minus y pi, derivate the whole term with respect to x. So this can be rewritten as dx. Now derivate x with respect to x and derivate pi with respect to x. You know pi is a constant term, so it will become 0, and x, we are derivating x with respect to x. This means just 1. So your derivation will be just 1. dy over dx is equals to 1. Okay, so far so good. But this means what? The same answer I will be getting from this implicit form. Yes? Okay, let's see. So first of all, as I want what? I want derivative with respect to dx. So the same I will be applying. So I will apply this operator d by dx on the left and the right hand side. Okay, so far so good. Now this is constant term. There is no x term here. So this means the derivative will be 0. Now this can be reduced to what form? This can be rewritten as derivative of x with respect to x, derivative of y with respect to x. Now this will be just 1. This will be just 1. And this is what? dy over dx. That's it. Okay, now this means your dy over dx is equals to 1. Here you got the same answer. So in this manner you can find your derivative of an implicit function. Okay, simple. Okay, this means you have to operate d by dx operator on the left and the right hand side of the implicit function. And in such manner you will get the answer of your derivative. Okay, one example you just saw. Now let us move next. Now in this case you cannot separate it. Okay, for now what? How you are going to just apply your operator d by dx, y plus sine y is equals to, again apply here, d by dx cos x. Okay, now this will be what? If you derivate it, what will you get? d by dx, this will become dy dx plus dy dx, this will become sine y. Okay, and this will be minus sin x. As you all know, derivative of cos x with respect to x gives you minus of sin x. Now this will become dy dx. Okay, what about this thing? So first of all, I have to derivate this with respect to x. Okay, and then how we are going to derivate it? Whenever you face something like this, d over dx and some expression in terms of y, which means some expression in terms of y. Whenever you see this, what you have to do is very simple, that write just dy by dx. That's it. And what you will do now, derivate your h with respect to y. That's it. You have to do this simple task. This means what? This means you have here dy by dx plus, first you have to derivate it with respect to y. This becomes what? This becomes, what can you say, cos y. This becomes cos y. Cos y, now just multiply with dy over dx. Dy over dx. You will get your answer. Now what can you take? You can take what? Dy over dx common, and what you will get? Let me just simplify it for you. Minus of sin x divided by 1 plus cos y. That's it. You will get your answer as this. Okay, you will get your answer as this, and obviously we are talking about when denominator is non-zero. This means cos y cannot be same as minus 1, and we know by using graph, as you can see, minus 1 will be where? This is your pi by 2. This is your pi by 2. Here you will get minus pi by 2. Okay. Sorry, this is your pi. Sorry, this is your minus pi. Okay, this is your 3 pi. Okay, 3 pi minus 3 pi. This means you are getting odd multiples of pi. So y cannot be 2n plus 1 pi. Okay, y cannot be 2n plus 1 pi. Simple. So keep this point in mind also. So clear? So implicit function derivative is very easy to find. You just operate your d by dx to both side, and whenever you find just y, just write dy by dx. If you find any expression in terms of y, for example here, you have to just what? Just derivative, find the derivative of the given expression in terms of y and then multiply with this thing. Okay, and then you will get your answer. Okay, clear? Now let us move to next. Now if you try to see that sine inverse x, cos inverse x and tan inverse x, the derivative is already given. Then how we know that these are the derivatives? Very simple, very simple. Let me just verbally tell you. Put sin x is equals to y. Okay, so far so good. Now put sin x is equals to y. Okay, so sin y is equals to x. Simple. So sin y is equals to x. Now derivate it, as it is our implicit function. If you derivate it, that will become what? As you all know, that will become cos of x. Okay, let me just write it. I'm going to give you only for one. So this means you first wrote sin inverse x is equals to y, and then wrote sin y is equals to x, and then it is my implicit function. Now derivate it. Sin y derivative, I am going to just directly write it down. So 1, as you all know, you are having y expression term. So this means just derivative with respect to y, you will get your cos y, and now multiply with dy over dx. That's it. You will get such sort of thing. So this means 1 by cos y. Now cos y, how you are going to find cos y? As you know, sin y is this. So this means you will have what? You will have x1, and this will be root of 1 minus x square. So far so good. Okay. This will be cos y will be, as you know, 1 minus x square. That's it. So this will be your answer for sin inverse x derivative. This means 1 by root 1 minus x square, as you can see, and this is what it is already given to you. In the same manner you can do it for cos x if you, and obviously, okay, so if you are taking it as equals to y, this means y must be in the range of sin x. This means -1 to 1. Okay, and x belongs to minus pi by 2 to pi by 2. Okay, x belongs to minus pi by 2 to pi by 2. Y belongs to what? -1 to 1. Sorry, x belongs to -1 to 1. Y belongs to minus pi by 2 to pi by 2. And at minus pi by 2 to pi by 2, cos y will be positive. That's why I wrote 1 by root 1 minus x whole 1 by root 1 minus x square, the whole terms in positive. That's why I wrote it in positive, because cos y, where y belongs to minus pi by 2 to pi by 2, it will be positive. Okay, simple. Okay, so that's the reason I wrote y plus 1 by root 1 minus x square. Okay, clear? This is for this. What about for cos x? The same steps will work. If you write cos here, that's it. Only change will happen is cos. Now derivative of cos will be minus of sine. Yes, this will be your minus sine y. Now the rule will be changed. Here you will use x, here it will be 1 minus x square, and sine y will be 1 by root 1 minus x square. So your answer will be this, as it is already written over here. Now for tan x, it will be very simple to evaluate. How? Just put it equals to y. This means tan y is equals to x. Now derivative of tan x, you all know, sec square x, sec square y. This means dy over dx will be 1 by sec square y. Okay, sec square y means cos y, and cos y you can directly evaluate without any problem. So you will get 1 by 1 plus x square, this term. Okay, I hope that you got it. Now, so please remember, memorize them, as we are going to use them a lot, as the questions, okay, are very there are many questions where we use our such information of sine inverse x derivative, cos inverse x derivative, tan inverse x derivative. In integration you will know that these are very important things. Okay, simple. Okay, now let us move to next. So here we have to find the derivative of f given by fx is equals to sine inverse x square, assuming it exists. Okay, very simple. So what I will be using is composition theorem, obviously. Okay, not composition, sorry, chain rule. I will be using chain rule. In chain rule, you all know I have to first of all find the derivative of this, then derivative of the outer function, and then multiply it. That's it. So derivative of inside thing will be 2x, derivative of outside thing, this means sine inverse. So sine inverse derivative, you all know, 1 minus 1 by this thing. So wherever x is written, I will replace x by this thing. Yes, so 1 minus x square means 1 minus this whole square. This means x power 4. Okay, so you will get your answer like this. Very simple. Okay, otherwise you can do it by what? Sine inverse x square, you write it as equals to y and then approach the same manner we did in just the previous slide. Okay, but do not go the long way. Just you have to remember is this thing, the chain rule, and you will get your answer quickly. Clear? Okay, simple, very easy. Okay, now let us move to next slide. Here, y is equals to sine inverse root x minus 1 root x plus 1. Then you have to find the derivative, dy over dx. Very simple. So how you are going to find it? As you all know, what? Very easy. The same thing I will do is, you all know, first of all I have to find the derivative of this. Okay, first of all I have to find the derivative of this. So finding the derivative for this, you will get what? So d over dx, you have to find the derivative of this thing. Okay, and then multiply with 1 minus root of derivative of sine inverse, which is 1 minus x square. What is our x? What I will use in place of x? This whole term. This means root x minus 1 root x plus 1 whole square. That's it. That's it. You will get your answer. So please solve this by using what? Derivative of what? If you remember, u by v whole derivative is just nothing but v square u derivative v minus v derivative u. That's it. Okay, do it by using this information and then you will get your derivative. Okay, I hope that it is clear. I'm leaving it for you. Why? Because if you do not practice it, you will not know that how we are using our chain rule, how we are using our quotient rule, and etc. Okay, and then how we are using our inverse trigonometric derivatives. Okay, let us move. I hope that it is clear. Okay, or let me give you another way. The another way is by using substitution. So first of all, what substitution you can make? So one substitution comes to mind is what? That if you put x is equals to, what can you put? X is equals to, if you put x is equals to cos square theta, if you put x is equals to cos square theta, then what it will be, the term inside will become what? Let me just write it for you. So cos theta minus 1 and cos theta plus 1. So it will be what? As you can see, so it will be, as you can see, 1 plus cos theta, 1 plus cos theta. If you remember, 1 plus, so for now, let me just not give you the idea of substitution. You will know what do we mean by substitution, how substitution is our work in derivatives. You will know, but not now. Okay, clear? So for now, please be strict to this process of chain rule and this quotient rule and sine or the inverse trigonometric derivatives. Okay, for now, after you get familiar with them, we will give you the substitution way of derivatives. Okay, now let us move to next slide. Here, so we have to differentiate it. Simply, how we are going to differentiate? One thing is very clear. If the same thing, the derivative will be, the first of all I have to find the derivative of the inside term, which will be like of this form. Now multiply with 1 minus root 1 minus x square. What will be my x square? This whole term. This means root of x plus 1. This means. So simplify it and you will get your answer. How you are going to simplify it? Very simple. The square will remove this root. You will have x plus 1. Okay, this will become x plus 1. X plus 1 minus 1. This will be x by x plus 1. Yes. Okay. Now derivative of this will be what? As you know, this will be square of this. Now root of this will be this, and this multiply with root of this thing. Okay, you will get this. So this means 3 by 2. Okay, or root of x plus 1. This means 1 by 2. This multiply with root of x plus 1 by root x. This will be cancelled. You will only left with 2 root x plus 1. Some expression like this. If I'm not making any calculative or any type of mistake, okay, you will get this answer. Okay, simple. Okay, and okay, I hope that it is clear. Simple. Okay, so what we just use chain rule. We just use inverse trigonometric derivative of sine inverse. That's it. And we also use the quotient rule. Okay, quotient rule, how we find the derivative of numerator by denominator thing. We just use that and found out our answer. Okay, clear? Okay, now just let me move further here. So here we have to differentiate it. Quite simple. How we are going to differentiate? The first thing is differentiate the inside thing with respect to x. So you will get a sine x. That's it. And now tan inverse differentiation. Tan inverse differentiation is 1 divided by 1 plus x square. What is our x? What x will be replaced? So x will be replaced by this whole term, which is, so x square means a cos x whole square. You will get your derivative as this. Okay, you will get your derivative as this. I hope that it is clear. Okay, simple. Okay, so what we used tan inverse x derivative, which is 1 by 1 plus x square. Okay, now here x will be replaced by the whole term inside the tan inverse function as a cos x divided by 1. Okay, so this will become 1 by 1 plus a cos x divided by 1, yes, whole square. That's it. Oh, and the inside term derivative will be what? As the denominator is 1, so no need to apply the quotient rule. I can just simply ignore it. So you will get a cos x. Now a cos x derivative will be, a is a constant, so this will be what? Will be untouched. Now cos x is the expression in terms of x, so this means it will be minus sine x. So that's why I wrote minus of ax. That's why I wrote minus of ax. Okay, simple. Okay, now let us move to next slide. So I hope that's it. We will end up here. So we will be back soon with the more problems of differentiability and continuity with more concept. I hope that now you are having some idea about the inverse trigonometric functions derivatives and the implicit function derivatives. So that's it for now. Thank you for your watching.